Hello students, today we will study about the area of a triangle. This is the topic of standard 10, chapter number 7, coordinate geometry. So in this chapter, till now we have studied the two formulas. One formula is to find the distance between 2 points. Second formula that we study is to find out the section. That means section formula. If a point divide the line segment in sum of the proportion, then we can find out that coordinate of that point using the section formula. Or we can also find out the proportion, that is suppose m1 and m2. We can find out that using the section formula. So today that is the third formula that we have to study of this chapter, and that is area of a triangle. So let us suppose there is a triangle A, B and C, right? A has the coordinate x1, y1, B x2, y2 and C has the coordinate x3, y3. So from all these coordinates, let us draw these perpendiculars BQ, AP and CR on the x-axis, right? So we have taken all this on the x-axis. So here what we want to find out is the area of this triangle, right? Okay, so here you can see that we have a study one formula, that is area of the triangle is what? 1/2 base into height or 1/2 base into altitude. Okay, so this is the formula by which we can find out the area of a triangle. Also in standard 9 you have studied the Heron's formula. Whenever we have given the sides AB, BC and AC, then using the Heron's formula we can find out the area of a triangle. But here we have given the coordinates A, B and C, and from that coordinate we have to find out the area of a triangle. So here we have to notice one thing is that whenever we draw these perpendiculars, three trapeziums are formed here. How many? Three trapeziums are formed here. One trapezium is ABQP. One is ABQP. Second one is APRC. Right? This is first trapezium. This is the second trapezium, APRC. And third one is BQRC. BQRC. Right? Because in all this trapezium, BQ is parallel to AP. That is, in ABQP, one pair of opposite side is parallel. In APRC, AP parallel to CR, right? And in BQRC, BQ and CR are parallel to each other. That is why all these three are the parallels. So how we can use the parallel to find out the area of triangle? See, this total area ABQPC. This is one side, second side, third side, fourth side, fifth side. This is a pentagon. This pentagon ABQRC, right, is divided into the three trapezium. First trapezium is ABQP, second one is APRC, and third one is BQRC. So the area of triangle we can write down here is the area of the trapezium ABQP, that means this much of the area. Area of the trapezium APRC, that means this much area. So total area is covered here. Using this two trapezium, the total area is covered, but we want only the area of ABC. So this much of the area we have to subtract, and that is what the area of the trapezium BQRC. So by adding the area of this trapezium and this trapezium, so we get the total area. Now we have to subtract this much of the area so that only ABC, area of ABC will remain. So here we have to add the area of this two trapezium and subtract the area of BQRC from that. So only the area of triangle ABC will remain. So now what is the area of the trapezium? The formula you have already studied in standard 8, that is 1/2 sum of the parallel sides into distance between them. Distance between them means distance between the parallel sides. Okay, so here first of all let us find out. See, this is in the first trapezium ABQP. These two sides are parallel, so the distance between them is QP. So QP, how we can write down QP? OP minus OQ. OP minus OQ. And what is OP? O to P means distance of P point from the y-axis. That is equals to the distance of A point, and that is what? X1. So OP is X1. In the same way, OQ means the distance of this Q point equal to the distance of B point, and that is what? X2. So X1 minus X2, we got OP minus OQ. In the same way, PR. How we can find out PR? PR means OR minus OP. OR minus OP. And OR we can write down as a X3, and OP we can write down as a X1. Right? In the same way, QR. Q to R is means OR minus OQ. OR minus OQ, and OR is what? X3, and OQ is what? X2. So this all QP, PR and QR are the distance between the parallel sides of all the three trapeziums. Okay. Now area of the triangle. We now apply this formula. Area of triangle ABC is equals to area of trapezium ABQP, that is one half sum of the parallel sides for the first trapezium. The parallel sides are BQ and AP. So one half BQ plus AP, distance between them, that is QP. In the same way, area of another trapezium, that is APRC. So one half AP and RC are the parallel sides, and distance between them is PR. For the third trapezium, that we have to subtract the area. One half BQ and CR are the parallel sides, and distance between them are QR. Now put down all the values. One half BQ plus AP. What is BQ? BQ. That means this point is how much far from the x-axis. That is the coordinate y. Y coordinate of this point is y2. That is y2. In the same way, PA, AP. AP means the distance between A to P. That is how much? The y coordinate of this point. That is y1. And QP is what? We have already find out, x1 minus x2. In the same way, now one half AP. AP is what again? Y1. And RC. RC is what? The distance of this point from the x-axis. That is the y3. And PR is x3 minus x1. That we have already find out. Now one half BQ. BQ is this again distance, that is y2. CR is again this distance that we have already find out, y3, and QR is x3 minus x2. Now here all these things, all the areas are in the form of coordinate. See, all what is this? y1, y2, x1, x2 is all are the coordinates of the triangle ABC. Now we have to simplify. So one half is common in all the three terms. Take one half as a common. Multiply this y2 with this two term. We get x1 y2, x1 y2, right? x1 y2 and x1 y1. Now multiply this x2 with both this term. So minus x2 y2 minus x2 y1. Now multiply this x3 y1, x3 y3. Now minus x1 y3 minus x1 y1 minus x1 y3. Okay, now multiply this term. Here this is the minus already is there. So first term we get is minus x3 y2 minus x3 y2 minus minus plus x2 y2. Okay, now multiply this with y3. So minus x3 y3 and minus minus plus x2 y3. So this is all how we multiply all the terms. Now let us simplify. What are the equal terms? We have to cancel out each other. x2 y2 is minus here, x2 y2 is plus here. So cancel out x1 y1 plus, x1 y1 minus, x3 y3 is plus here, x3 y3 is minus here. So now all the terms that are we can subtract, we have done. Now write down one half as it is. Now see, this is x1 y2. Where is the term? Find out which is x1. See, this is x1 y2, x1 y3. So here we can write down x1. If we take x1 from the common from both this term, we get y2 minus y3 in the bracket, right? x1 is the common, so y2 minus y3. Now in the same way, this x2 and this x2. From this two term we can take x2 as a common, x2 as a common. So from this, if we take both this term x2 as a common, what will remain? Y3 minus y1. And now this x3 term and this x3 term. From this two term we can take x3 as a common. We can take x3 as a common. Now what will remain? Y1 from this term and y2 from this term. Right? So now all the terms are covered here. See, no terms will remain. So this is what we get the area of a triangle ABC. Right? It is easy to remember. How we can remember it? 1/2. First of all take x1. Right? First of all take x1. Then here we have to subtract y2, y3. So 1, 2 and 3. Plus here if we have taken x1, take x2. Now 2 is already there. So 3 and 1. Now x1, x2 already are there. Take x3. So here we have to subtract 1 and 2. So no coordinates are repeating here. Like x1, y1 are not there. 1, 2, 3, 1, 2, 3 and 1, 2, 3. So all this in this way you can remember this formula. So in this way we can find out the area of triangle ABC only by the coordinates. See here there are only the coordinates, right? So this is the area of triangle and this is all about this lecture. Okay, thank you.